Welcome. So this is a projectile motion question, which means that the object travels through two-dimensional space with only the force of gravity acting on it. This question says a cannonball is fired with a muzzle speed of 4 meters per second horizontally off a cliff. If it takes 3 seconds for the cannonball to hit the sea, what is the range of the cannonball? So again, I like to do my own diagram. So here's the cannonball being fired, and this is 4 meters per second. And then we have a cliff. We can have the sea underneath, and the actual path followed by the cannonball will be a parabola. And we can define the range, and the range is the distance horizontal, the horizontal distance traveled across a plane or across the sea or whatever. Muzzle velocity is the velocity with which the cannon ball leaves the cannon. It's the velocity at the muzzle. And we can think of this as the start of the journey, and we can think of this as the end of the journey. And so we need to find our horizontal displacement. So basically that's what this question is saying. What is the horizontal displacement? I find horizontal information using horizontal information. It sounds obvious, but if you don't visualize it, it's easy to get things confused. So if I look at my diagram, my V initial at the start of my journey is equal to plus 4 meters per second. It's plus because it's moving to the right. And I know that my delta t, my time for my journey during this projectile motion, is 3 seconds. And I know that my acceleration in the horizontal direction is 0 meters per second squared. Now, sometimes people put down minus 10 meters per second squared because they get used to associating minus 10 with acceleration. But in these problems, you have to carefully distinguish between horizontal information and vertical information. There is no force acting horizontally on the cannonball. But hold on, what about the cannon? That force was before the journey that we're talking about started. We're talking about the projectile motion part of this journey. And the projectile motion, by definition, the only force acting on the object is the force due to gravity, and that causes an acceleration due to gravity. There's no force moving sideways. There's only inertia carrying the ball sideways. So our projectile motion begins the instant after the cannonball leaves the cannon and the instant before the cannonball touches, in this case, the sea. That's why, for example, V final is not 0. V final horizontally is not 0 because the ball stops moving. Our journey ends the instant before the cannonball hits the sea, and at that instant, the cannonball is still traveling sideways at 4 meters per second in the positive direction. It's not been modified by an acceleration whatsoever. So can you see there's a lot of hidden information in these problems? There's a lot of conceptual understanding that is imperative for the correct solution of a problem like this. We want to find the range, and the range is equal to my horizontal displacement, which I don't know. So now I need to do some, I want to select from this information the equation that I need. And I have a delta x, an a delta t, and an I. So the obvious equation is delta x is equal to vi delta t plus 1/2 a delta t squared. and my horizontal displacement is equal to my initial velocity horizontally, which is +4, times my overall time, which is 3 seconds, plus 1/2 times my horizontal acceleration, which is 0, times my time squared, which is 3 squared. So my horizontal displacement is equal to +12 added to, well, 0. Multiply anything by 0 and you get 0. So delta x is equal to +12 meters. So, and if I look on the side, I can see it's answer D on this. So I'm hoping you're getting from this that we need to be careful about separating vertical information from horizontal information, but we've also got to have a lot of conceptual understanding. We've got to really understand the concepts of what's going on so that we don't make false assumptions about the question. And there we have it.